This is a Middle Loop class.
Hi, I'm Jerry with Middleloop, and today, how to get high-resolution panoramic images from a drone. Most drones have a feature that can produce a panoramic image in a single click. But is this the best method? The short answer is no, at least not if you want the highest resolution possible. Today, we show how to get high-resolution panoramic images, even if your drone doesn't have the automatic feature. We tested 3 methods and will show a side-by-side comparison of the results. As always, we start out with a quick overview. Next, we describe the methods we tested and how they vary. Then the results, where we show a side-by-side comparison of the images produced. Besides image quality, there are other benefits to each method tested. We'll go through them. Finally, we provide details on how to manually shoot the photos to be used in your panorama, and we include the settings and some tips to get the best results. The drone we're using today is the DJI Mavic 3 Cine. This drone has that single-click feature. That'll be our first method tested. If your drone doesn't have that feature, we show that too in our second and third methods. This drone has a dual camera system. In the second method, we use the main Hasselblad camera with its 4/3 20-megapixel sensor. And the last method tested, we'll be using the secondary telephoto camera, which has a 1/2-inch sensor. As I said, we ran 3 separate tests. First, the one-click automated feature, and then 2 methods where we manually capture the images. Spoiler alert, if you want to jump ahead to the method that produced the highest resolution, that's method number 3. The first method we tested is the automated one-click method. The drone we used has several options for this. We're using the 180-degree option. It couldn't be easier. You just put the drone up in the air, point it at the center of the subject, and click Start. The drone immediately gets to work taking 21 overlapping images, and then it automatically stitches them together to produce a single panorama. And here's the image it produced. The file produced, at least on this drone, is a JPEG at 72 ppi. The next method we tested was completely manual. Basically, we mimicked what the drone did automatically in the first method. The key difference here is that by taking the images manually, we were able to save them in the RAW format at 300 ppi. In this test, we used the primary camera with the 4/3 sensor. This is the same camera the automated feature used in method number 1. Once the images were captured, we stitched them together using the Photo Merge feature of Adobe's Photoshop software. Finally, method number 3. As we said, this method ended up producing the highest resolution panorama. We'll compare the results in a moment. This method is nearly identical to the last method. In both, we captured the images manually and saved them in the RAW format. The only difference here is that this time we set the drone to use the telephoto camera with the 1/2-inch sensor. That's right, the 1/2-inch sensor at 12 megapixels produced a higher resolution panorama than the primary camera with the 4/3 sensor at 20 megapixels. That's because this camera has a lens with a focal length that's 7 times that of the 4/3 sensor, which means it takes a lot more photos with a lot more pixels to cover the same area. Here are the 3 panoramic images produced by each method. It's a little hard to tell how the resolutions compare, so let's zoom in. And when I say zoom in, I mean way in. Let's start with the panorama produced by method 1. If you look close, you might be able to see a city way off in the distance. Let's zoom in. Now let's add the image produced in method number 2, zoomed in to match. And now method 3. Methods 1 and 2 produced images which are very similar. That makes some sense since both were taken with the 4/3 sensor. Method 3, which was shot with the telephoto camera, produced by far the highest resolution of all. The bottom line is use a telephoto lens, if possible, to produce the sharpest, highest resolution panoramas. Clearly, method number 3 produced the highest resolution panorama. However, there may be more to consider. Let's go over each method and discuss some of the other benefits worth considering. The most obvious benefit here is speed. If you're just looking for a quick panorama, this is clearly the way to go. It only takes about a minute, and because it's stored as a JPEG, the size of the image file is much smaller than the other 2 files. Obviously, the smaller the file, the less room it takes up on your hard disk. And it also reduces download times, which might be better for sharing in social media or on a web page. Okay, so the image produced with this method wasn't much different than the automated method, and it took a lot more time to produce. So why do it? Well, there are a couple more benefits to consider. First of all, it doesn't require a drone with a special feature. Any drone will do. Also, as we said, you can choose to save the images in the RAW format. RAW provides much more flexibility in post-processing. More colors are retained and better dynamic range. It handles underexposed and overexposed images better. And because you're taking the source photos manually, you control the width and height of the final image. Plus, at least with this drone, the images captured in the RAW format are at 300 ppi versus the 72 ppi JPEG captured in Method 1. 300 ppi is pretty much the standard for printing in large formats. This method has all the benefits of method number 2. Plus, of course, it generated the highest resolution image. However, it will take longer to capture and to stitch together. And it'll take up a lot more disk space. When shooting the source photos manually for a panorama, as we did in methods 2 and 3, here are some tips. Don't use digital zoom. Most drone cameras have a prime lens, meaning the focal length is fixed. For example, the drone we used has 2 cameras. The primary Hasselblad camera has a prime lens equivalent to 24 millimeters. The telephoto camera's lens is 162 millimeters. Drones typically can also zoom in digitally beyond the optical focal length. For example, this drone can go to a magnification of 28x. This is accomplished electronically by stretching the image and filling in the gaps with pixels using mathematical interpolation algorithms. Anyway, don't do it. The native optical focal length of the lens provides the best possible image quality. When shooting images, overlap by a third. Lenses tend to distort images more on the edges. If you overlap by a third, the process of stitching the images together will use more pixels that were taken from the sweet spot of the lens. Use manual mode for shutter, aperture, and ISO. Set them and leave them so they're the same for every photo in the sequence. We recommend setting these while pointing the drone at the brightest spot of the landscape being captured. With digital photography, it's always better to underexpose rather than overexpose. We also recommend choosing the best ISO for your sensor. In my case, we manually set our ISO to 100. Once the ISO is set, a simple way to set the shutter and aperture is to let the drone adjust them in auto mode and then switch off auto mode to lock in those settings. Manual focus. Here too, you're better off setting this to manual so it's the same for every photo in the sequence. Start with it in auto mode. Tap the screen to focus on your subject and then switch it back to manual mode to lock in the focus. Using an ND filter is fine. However, we don't recommend using a polarizing filter. The angle of the sun can cause the exposure to change. Last tip, put the drone in C, cinematography mode for more finite control while shooting the images manually. This will make it easier to overlap each image by a third. And that does it for this quick class. If you found this video useful, please subscribe. We have a lot more drone-related videos. Thank you, have a great day, and happy flying.